Hello everyone, my name is K. Rajesh. I am from CSE B section. Today's my topic is about the DNS in IoT, opportunities, risks and challenges. Introduction. The Internet of Things (IoT) is an emerging internet application that extends network connectivity and computing capability to objects, devices, sensors, and items not ordinarily considering to be computers. The IoT is expected to connect 20 to 30 billions of such objects to the internet in the next decades, with some analytics even predicting 100 billion connected objects by 2025. Examples of IoT application areas include smart homes, which connected kitchen applications, toys, light bulbs, smart cities with connected street lights, and environmental sensors and self-organizing dynamic networks of drones and robots. The key difference between classical Internet of Things and the IoT is that the former typical enable humans to interact with the content and services, example through web browsers, whereas IoT application typically operate in the background as a integral and invisible part of people's life. Conceptually, the IoT accomplishes this by continually interpreting and updating the distributed online representation of physical environments, database, and data from the wide ranges of sensors, and then using the representation of is act upon the real world through authors, all typically without a direct human's involvement or awareness. This continually and intelligent sensor interpret act loop promises to enhance our daily lives. For instance, through a smart wrist watch that automatically opens the front door of our house and adds various bio measurements, example movement of heart rate patterns, and our medical file. Another important difference is that the applications on IoT devices are typically control programs that run on widely heterogeneous hardware, CPU architectures, and operating systems. This is unlike today's web-based internet applications, which typically runs on a relatively homogeneous devices like laptops and mobile phones. The DNS and the IoT. The IoT revolves around the concept of the IoT deployment, which we define as the combination of a group of IoT devices that senses and act upon the physical environment. The remote services on the internet that the IoT devices use to provide their functions, and DNS services they interact with. We also reuse concepts for the extend them to include DNS interactions for service discovery. We envision this that the IoT will consist of many heterogeneous deployments in terms of application areas, in, uh, interaction facilities, operating system, and network capabilities. Data transfer in IoT deployments. D1 sensors are users' movement and heart rate, encodes this information in a stream of IP packets and sends it to the S1 for analysis. The traffic flow typically reaches the remote services via the edge network in which the device resides and several intermediate routes and networks. S1 interprets the measurements using application-specific logic and automatically sends instructions to other devices in the house. For example, it could use the biometric information from D1 sensors to identify the users and automatically instruct the lock on the front door to open when the smartwatch is near it. At the same time, S1 could send instructions to turn on the lights in the house and interact with the other devices in the house. Opportunities for the DNS to protect the physical world and increase its transparency. IoT deployments introduce new security, availability, and transparency requirements because they interact with the physical space, often without human involvement and awareness. This is an opportunity to further increase the value of the DNS because it is a global pervasive infrastructure that can help in fulfilling these requirements. Specifically, the DNS allows IoT devices to automate authenticate resolvers and encrypt DNS traffic supports. Message authenticity provides additional ways for IoT devices to check the viability of the services they connect to, and offers an opportunity for registration providers to provide additional security services for IoT deployments. Using DNSSEC to detect malicious redirects of IoT devices. DNSSEC provides message integrity in the DNS, which means that resolvers are able to detect adversaries making changes to the content of DNS messages. This is practically important in the IoT because manipulated DNS messages can redirect IoT devices to the malicious services, which jeopardize users' privacy, satisfy, and well-being. In addition, users may not be aware of such redirections, for instance, because devices may be non-interactive and operate um, autonomously. This is unlike a traditional internet applications where it is in this typical case users explicitly interact with remote content of services. A particularly relevant type of attack that DNSSEC helps to detect in Border Gateway Protocol (BGP) hijacks, which occurs routinely on the internet. BGP hijacks are unlike DNS catchy poisoning attacks that directly target resolvers, and which DNSSEC was originally designed to protect against. DNS catchy poisoning attacks are partly being mitigated by modern resolvers using better port randomization. Routing hijacks will likely continue to occur for some time because partial solutions to protect against them are being deployed, but but have not reached ambiguity deployment yet. DNS protocols to double check the authenticity of IoT services. There also exist several DNS based security protocols that provides IoT devices with additional means of check the authenticity of the certificates they receive from the services after DNS resolution. Similar to protecting the integrity of DNS message, this is important to avoid IoT devices talking about malicious services that would impact the privacy and safety of users. For example, in DNS based authentication of named entities, which enables IoT devices and gateways to validate the transport layer system security. Certificates that they receive, such as when they connect to the remote services through HTTPS, for example, if device D1 uses HTTPS to connect to S1, it can look up S1's certificate in the DNS. Similar to the protecting the integrity of DNS messages, This is important to avoid IoT devices talking to malicious services that could impact the privacy and safety of the users. Protecting IoT devices against domain registration hijacks. Registries and registrators are in the unique position to provide IoT specific services that contribute to the safety, privacy, and transparency of the IoT for end users. For example, the registrator of SP1. This lowers the probability of a domain hijacking, which occurs when someone makes unauthorized changes to S1's domain registration information such as DNS records, resulting in IoT devices querying for S1 and ending up at the different services. The effect of a domain registration hijacking is similar to the effect of a manipulating DNS transaction, except that the hijack occurs on the registration side and can modify DNSSEC signing keys. Conclusion: the IoT is an emerging distributed application that is expected to further case our daily lives and make our society safer and more sustainable by autonomously and seamlessly interacting with other physical world through billions of connected sensors and actuators. A significant number of IoT devices will likely be IP enabled and will use the DNS to locate the remote services they require to perform their functions. As a result, the DNS will continue to play the same crucial role for the IoT that it has the traditional applications that enables human users to interact with services and contents. Thank you.